Now, in the last lecture, we started chapter number 4. And the highlights of chapter number 4, I told you that we wanted to look at the history of astronomy. And we talked about archaeoastronomy, where we look at old monuments and you want to see some astronomical significance in these monuments and so on. And the said we need some documentation, and we said basically the preserved documentation is the documentation of the Greeks. And we said the model of the Greeks basically based on first principles, which geocentric universe and perfect heavens. And the model was basically on the Earth being the center, and that's why we call it geocentric universe, where the Earth is the center and the celestial bodies basically orbit around the Earth. And then we said this model was not really a good model that can explain the retrograde that we see for Mars, and Thales basically added the epicycles, and we talked about the effect of this epicycle was introduced to explain the effect of the retrograde. And then we talked about the era of the Muslim civilization and how astronomy was important to Muslims. And they introduced the concept of observatories and the use of tools in observations. And we talked about the different observatories through the the history of the Islamic civilization. And we talked about the different types of tools. And then we went to the Copernican revolution, and Copernicus presented a model in where now the view should be changing from geocentric to heliocentric universe, where the sun is the center, not the Earth. And it's the explanation of retrograde is easily explained rather than the complicated way of the epicycles. We also talked about Galileo Galilei. He did not invent the telescope, but he was aware of the invention of the telescope, which came around the end of 1608. In 1610, he pointed the telescope that he made to the sky and start making discoveries. And he discovered the 4 Galilean moons around Jupiter, so Jupiter is not alone. He looked at the surface of the moon, which is basically not, it has mountains and valleys, and it's not perfect sphere, which goes against the tenets of the Greek model. The same thing happens for the sun. These are not perfect spheres. And then Venus made phases like the moon, and the only explanation for this is if the Venus orbits the sun. And I think in chapter number 3, when we talked about the observation of the crescent to signal the beginning of the lunar or the Hijri months, and in 2020, I think on May 22nd, to find a crescent of Eid al-Fitr, some places in Africa, they witness a crescent through a telescope. But actually, it was not the crescent of the moon. It just happens that sometimes the Venus and the moon, they could be in the same western skies. So sometimes you may be fooled with this. So now, as I told you in chapter number 3, in astronomy, now we know how the moon orbits the Earth and how the Earth is orbiting the sun. So when you can exactly, from calculation, we tell you that either you saw a crescent or not. And that could bring in a confusion. And people will swear that they saw a crescent, and it was above the western horizon and so on, and just after sunset. But actually, it's for Venus, not the moon. So that's one of the things that Galileo Galilei discovered, and he concluded that actually the sun should be the center, not the Earth, and that basically an evidence for the model of Copernicus. And then we went through of how in history of some importance of astronomy, of how the solar system was basically the orbits of the planets in the in the solar system were corrected from being uniform circular motion, as is it in the Copernican model, to elliptical orbits. And we basically talked about Tycho Brahe, which he did careful observation, and that basically goes to his credit. And then we talked about Johannes Kepler, who got hold of the data of Brahe, and he modeled and he concluded that the orbits of the planets around the Earth, around the sun, are elliptical, not circular, and that's what's wrong with the Copernican model. And I told you that's the story of how science work. It takes time to develop, and we told you that the eccentricity, which is how much the orbit of the Earth deviates from a circular path to elliptical path, is very small, which if the observations are not careful, it may actually fool people in thinking circular orbits may be possible. And we talked about the 3 laws of Kepler. The first law, that the planets orbit the sun in elliptical orbits, and of course it does that with varying speed, that means non-uniform circular motion. And then Kepler's 3rd law, where the period squared should equal to the distance from the planet to the sun cubed. That was basically what we did in the last lecture. Now, by this time, the view was basically changing from geocentric universe to heliocentric universe. Today, we're going to present here a slide. And this slide here, it tells you that we have 99 years of astronomy. That was a good time for astronomy, where the view basically and evidence were provided to shift from what we call geocentric universe to heliocentric universe. So you can look here and you look at the time of Copernicus. And at the time of Copernicus, we have Columbus and the discovery of the Americas, and we have Leonardo da Vinci and Magellanic Voyager around the world. So it is, by the way, when you talk about discoveries and invention and advances, these have to be done within a civilization. And that's the time of the Renaissance in Europe. Now, you look at this time when Praha was making his careful observation and carefully recording the data, where the time of Kepler, who got hold of this data, where he modeled and he came up with the conclusion that the orbits of the planets around the sun should be elliptical, and the time of Galileo Galilei, who was the first to point a telescope to the sky and start making discoveries where giving strong evidence that actually the sun should be the center and not the earth. However, during this active time here, you can see Shakespeare. So it is a civilization. It's a complete civilization where these things were basically done. So you really have to have the infrastructure to do all of this. Now, at all of these times, it was not known why, what is the source that keeps the planet orbiting the sun. And that basically came later with Newton, Isaac Newton, who discovered that things fall down because of gravity. And he said, well, the sun exerts a gravity on the planets, and that's why the planets are orbiting the Earth. So he came up with a law where it says that the force is equal to G m1 m2 over r squared, where the r is measured from the center of the two objects, and this is mass 1 and this is mass 2, and that's basically a constant here. So with this, Newton explained why the planets are orbiting the sun. Nowadays, we know that the sun is not the center of the universe. It's basically a star from one of 200 to 400 billion stars in a galaxy called the Milky Way galaxy, and the Milky Way galaxy is one from trillion, maybe a trillion galaxy in our own universe, or what we call the observable universe. So we don't know where the center of the universe is. But we know that the sun is only the center for the solar system. So what we try to do in this chapter is basically to take you through a history of how the view changes. And this is also in science. And you always have to be open to these possibilities. And remember what I told you about the scientific model in chapter number 1. You make a hypothesis, a theory, and you start testing, and you go on. So what I have up here as a scientific argument, why would one say that the Copernicus hypothesis was correct, but the model inaccurate? So the hypothesis was that the planet basically orbited the sun. And he made a model to explain that. But later on, Kepler explained that actually what's wrong with this model, that uniform circular motion does not explain correctly how the planets orbit the sun. And then through his modeling, he said basically the orbits have to be elliptical orbits with non-uniform circular motion. And with this, basically, the model of the solar system more or less is complete. Now we actually know exactly of how the planets are orbiting the sun and the moons orbiting the planets, and we can model these things, and we know precisely where the position is. So we came a long way. So now we have about 400 years of heliocentric universe. But I told you now we don't believe that the sun is the center of the universe. It's just a star on a galaxy, and there are a huge number of galaxies. So if we try to just have some summarizing points here for this chapter, Greek astronomy was based on geocentric universe. Islamic astronomy revised the Greek astronomy and introduced the concept of observatory. The Renaissance astronomers refuted the geocentric model and supported the heliocentric model. Kepler's three empirical laws explain the motion of planets in the heliocentric model. So by that time, the view was changing, and I think even in Europe, a clash came between religious beliefs and scientific discoveries, and that gave rise to different things, but that's not our discussion here. But astronomy was a driving force for that. It changed the views of probably politics and things later that came. Probably some people always say even the French Revolution. It's because of these things that took place. And now we strongly believe in advance of science, and we live in a time now we're all in a lockdown because of the coronavirus, but you can see scientists are working on finding a cure, and there are a number of vaccines around, and many are vaccinated to protect themselves. So now we actually, science plays an important role in humans' life. Any questions on what we presented so far? Any question on this? Okay, what's left for us to do? We're going to look at the review questions, and there are not too many here. Okay, the first question here and the multiple choice question: which of these were things ancient Greek astronomers never considered in astronomy? The Earth is round. Everything in the universe goes around the Earth. The Earth goes around the Sun. Actually, they considered all of these things. But I told you about Einstein, who calculated even the circumference of the Earth. But of course, the dominant and accepted belief was that the Earth is the center of the universe. Almagad is a collection of the science of the mathematics of the Greek. Epicycle is a circle whose center is located on the circumference of another circle, and I told you this is introduced to explain the retrograde motion. The Ptolemy's model of the universe contained epicycle. That's the right answer here. Hippocrates introduced the concept of eccentricities and the epicycle to planetary motion about Earth. It created the star catalog and generally credited with the development of trigonometry. 6. The distance from Alexandria to Syene, which is Aswan, now in Egypt, where there is the dam, is about 500 miles. On the summer solstice, the sun is directly overhead at noon in Syene, at Alexandria on the summer solstice, the sun is 150th of the circumference of the sky, about 7 degrees above the zenith. Based on this information, what is the circumference of the Earth? This is basically what Einstein did. He said, if we consider a circle like this, the circumference of this circle is equal to 2 pi r, where r is the radius of the circle. So if you take any part of this circle, this will be the arc. And this arc here, we can call it S. S will equal to r theta. If you go around a full circle, you get 2 pi. So if you look at the distance between Alexandria and Sinai, I was saying, it was this distance here, which is about 500 miles. And the angle here about 7 degrees. And you know, when you go around, it's about 360 degrees. So he concluded, I think it was 7.2. So he concluded that the distance between Alexandria and Sinai is about 150th from the whole circumference. So if you multiply that by 50, you will get the circumference of the Earth. And that's basically how he got this distance of 25,000 miles, which is it's a good estimate. It's within 4% or something like this today. Which of the following people did not accept a heliocentric model of the universe? Tycho Brahe, he did not accept that, even though he had good data and he actually came up with a model of the universe, but he insisted that the Earth is still the center. 8, the book of the revolutions of celestial bodies first described the Copernican theory, and that's basically what Copernicus model that he presented. 9, the Copernican system was no more accurate than the Ptolemaic system in predicting the positions of the planets, because the Copernican system included uniform circular motion. 10, Brahe's universe was the same as the Copernican, except that the Earth didn't move. I told you, if you look at the model that Brahe came with, he actually said everything revolves around the sun, except that the Earth revolved around the Earth. And more or less, they are the same, except that the Earth did not move. Tycho Brahe's greatest contribution to astronomy was his years of careful observation of the planets. 12, Galileo's observation of the gibbous phases of Venus proved that Venus orbits the sun. 13, Galileo's telescopic discoveries of mountains on the moon and spots on the sun were controversial because they suggested that the sun and moon are not perfect. And that goes against the principles of the Greek model, where they said the heavens are perfect spheres. 14, Galileo's telescopic discovery of moons orbiting Jupiter was important because it showed that the universe could have centers of motion other than the Earth. And Earth might move along an orbit and not leave the moon behind. So the answer here is A and B. 15, A model is a description of some natural phenomenon that can't be right or wrong. It's merely a convenient way to think about a natural phenomenon. A theory is a system of rules and principles that can be applied to a wide variety of circumstances but not be universally accepted. So just trying to give you here the difference between a model and a theory. 17, in pre-Copernican astronomy, it was almost universally believed that the Earth was at the center of the universe. An apparent westward motion of a planet in the night sky compared to the background stars as viewed from the Earth when observed on successive night is referred to as retrograde motion. Remember what I told you, that things always try to move toward the east. So Mars is moving east in the sky every night. But because the Earth is moving at a faster rate, we can catch up with Mars. And it seems that Mars is moving opposite. That's why we call it apparent westward motion. And of course, the epicycles were introduced to explain this. So we say that the purpose of using epicycles and different to explain the motion of the planets in the night sky was to account for this retrograde motion. 20, which of the following object cannot transit, that is, pass in front of the Sun as seen from Jupiter? So if you know the order, it is the Sun, then after that you have Mercury, Venus, Earth, Mars, then Jupiter, then Saturn. So Mercury, Venus, Earth, Mars, they can transit between the Sun and Jupiter, but of course Saturn cannot do that. So the answer here is C. 21, the greatest inaccuracy in the Copernicus model of the solar system was that the planet traveled in circular orbits with uniform motion. And that's what Kepler corrected. 22, which of the following planets cannot be seen as a crescent phase from which of the following planet can be seen as a crescent phase from Earth? Well, Mercury and Venus, but remember when we talked about Mercury, Mercury usually hangs around for a few minutes just before sunrise or just before sunrise in the east or sunset in the west. But Venus can be around for a few hours after sunset in the west or a few hours before sunrise in the east. That means in the morning sky. And this is where I told you that we have to be careful if we are trying to look at the crescent for the beginning of the Hijri months. And that's what happened in 2020 when we were looking at the crescent for Eid. And it just happened that Mercury, Venus, they were actually at the same location or in the same general area where you can basically spot a crescent. And at that day, the crescent was not old enough to be sighted with a telescope, but some actually in Africa, they sighted with a telescope a crescent, and they swear they are sighted the crescent, and they actually right in that, but it was not the crescent of the moon. And I tell you now that knowledge of astronomy is probably spreading, and we now know the different, and I told you about the different conditions of how you look at the crescent, and I think I advise you not to, because each one can argue, and I don't like to see fighting and things like that. So now things are clear. Astronomy is very clear on this, and I will leave it up to the decisions of different countries and so on to make their own decision. But I don't want it to be an issue where Muslim fight over. There are many important things that we have to worry about. I think from my point of view, is the most important thing is how to make science very important for us. And you can look at the situation that we have now. Many nations are developing vaccine against the coronavirus and trying to find the cure. And the only thing that we're doing is basically waiting for them to develop this. So we really have to concentrate on the important issues first before we go into side issues that sometimes are not that crucial. Okay? And with this, I think I'm going to cap here chapter number 4. Do you have any question on this? Do you have any question on these? Are these points clear? Good.